Welcome to Mobile Math lessons on the go. Today's learning goal: by the end of this lesson, I should be able to multiply together two decimal numbers that have hundredths in them without the use of a calculator or any other technology. Quick reminder of where our decimal point lies and what the terms are. So we start with the ones as sort of the focal point in the middle. As we move out, we have tens and then tenths. When it has a TH on it, that means we're talking about smaller parts of a whole. So as we go to the right, we're getting smaller. As we move to the left, we're getting larger. Our two big ideas so far: when we multiply by a decimal that is less than 1, the product should get smaller. So for example, I am multiplying 6 times 0.2. The 0.2 is less than 1. My final product here is less than the 6 I started with. If I multiply by a decimal that is larger than 1, my product should get larger. So you'll notice I have 6 times 1.2, or 1 2/10. So I'm multiplying by a value larger than 1, so that my product or final result is 7.2, which is larger than the 6 I started with. So let's just do a quick refresher. We have a number model, an area model, and a column model for multiplying them decimals together. So if we find the product of 3 times 4 1/10, or 4.1, I can use my number model. I can break up the 4.1 into 3 groups of repetitive addition. I can break those numbers down further. I've collected the whole number 4's together to get a 12. I've collected the 3 tenths together to get 3 tenths, and my total is 12 3/10, or 12.3. I can use my area model. 3 times a 4 is a 12. 3 groups of 1/10 are 3 tenths. If I add those together, I get the same value. And then we also looked at something called the column model, where if I multiply 3 times 1, I get 3. 3 times 4 is 12. And I have to keep track of my decimal point. So we have 3 different models that we've explored. Today we're going to focus on the column model the most. So the column model uses the least amount of correct mathematical language, but the pattern solution does provide us with a very efficient solving technique. So you really should have a good grasp of what's happening in the number model and the area models before you move into the column model. But the column model will allow us to deal with some very complicated problems in a very efficient manner. So we're going to look at the product of 6.5 times 1.5, 6.5 times 1.5, 6 5/10 times 1 5/10. There's a whole bunch of ways of saying this. Right away, I'm looking at this and saying I am multiplying 6.5 times a value that's larger than 1, so I expect my answer to be larger than 1, or larger than 6.5. So I've already got that idea in my head. So column model number 1, and I just have a little reminder down here that when we multiply by 0.5 or 5 tenths, 51 hundredths, 1/2, those are all the same thing. So 0.5 is the same as 1/2. So when I do my column model number 1, I have a half times a half. Well, half of a half is a quarter. So that would be that piece. And then I have a half times 6, which is 3. And I may put the decimal points in just to keep track of everything. I then might multiply 1 times a half, which would be a half, and 1 times 6, which is 6. And if I add all that together, I end up with 9 and 75 100ths, or 9.75. In column model number 2, we talked about this model being fairly efficient and quick, but it did have some language issues. So I will say it again the way most people say this solution, and then we'll look at where the decimal falls. So I will start with the 5. So 5 times 5 is 25. Carry the 2. 5 times 6 is 30, plus 2 more is 32. I need my 0 placeholder because I'm moving over one column, one place. So 1 times 5 is 5. 1 times 6 is 6. When I add those two together, I end up with 975. Now here's the key: I have to know where to place that decimal point. And with column model number 2, we found that if we count up the number of decimal places in the original question and then I jump over, I end up with the correct location of where to put the decimal point. And again, I'll remind you that if you look at these two here and these two here, they make up the parts. So the parts of column model 1 show up in column model number 2. So again, column model number 2 is mostly for when you're really, really comfortable with what's going on. So not a place to start, but maybe a place to finish. So we're going to try multiplying by some larger decimals. So I have 3 and 52 100ths times 2 and 4 tenths, or 3.52 times 2.4. So right away I see that I'm multiplying the 3.52 by a value greater than 1. So I expect my answer to be larger. And I'm going to introduce this concept right now, this idea of an estimate. When you start to get more complicated decimals, it's a good idea to know what your answer should be, sort of, at least what a close answer. So I'm going to look at my estimate here with some friendly numbers. So I'm going to look at the 3.52. I'm just going to see that as a 3.5. And the 2.4, I'm just going to see that as a 2. So when I look at this, I see two groups of 3.5, which would just be 7. So I know my answer from the big decimal question here should be close to 7. It may not be exactly the same, but it should be close. So let's try column model number 2, and again I will say this the way people are going to try and explain it. 4 times 2 is 8, 4 times 5 is 20, carry the 2, 4 times 3 is 12, plus 2 more is 14. I move to the second line. I need a placeholder of a 0 because I've moved over one column. 2 times 2 is 4, 2 times 5 is 10, carry the 1, 2 times 3 is 6, plus 1 more is 7. If I add up all of those columns, I have an 8, 4, 4, 8. Now the only thing I have to figure out is where does my decimal place go, because there's no way that 3.52 times 2.4 could equal anything close to 8,000. So if I count up my decimal places, I notice there are 3. So if I jump my decimal place over, I end up with a value of 8 and 40, or 8.448, or I can say this as 8, and you ready for this? 448 thousandths. So if we compare our two answers, I'm at least in the right ballpark. I should know that the 8,000 answer, it was completely incorrect. So let's try a little bit larger. Again, we're going to use an estimate with some friendly numbers just to keep track of what we're looking at. So 6 and 78 100ths, or 6.78. I'm going to say that's close to a 7. And then 3.45, I'm going to say that's close to a 3. I'm fairly comfortable with my multiplication facts now that 3 times 7 is 21. So I'm expecting an answer in the 20s, somewhere around the 20s, something. So let's try this. And I will use different colors here because we're going to have 3 different rows here. So this is going to be a new one for us for column model number 2. 5 times 8 is 40. Carry the 4. 5 times 7 is 35, plus 4 more is 39. Carry the 3. 5 times 6 is 30, plus 3 more is 33. Move to the 4, so I need a 0 placeholder. 4 times 8 is 32. Carry the 3. 4 times 7 is 28, plus 3 more, so it's 31. Carry the 3. And 3 times 8 is 18, plus 3 more is 21. So you can see how these start to get complicated. I'm on my second line, or my third column now, so where the 3 is, so I need 2 placeholders or decimal places. 3 times 8 is 24. Carry the 2. 3 times 7 is 21, plus 2 more is 23. And then 3 times 6 is 18, plus 2 more is 20. So let's add up all those columns. So I have a 0. Now 9 and 2 is 11. I have to carry 1. 3, 4, 5, and 4 more is 9. 7, 2, 2. And I get this really big number. So obviously the answer to a 6 times a 3 can't be anywhere near 227,000. So if I count up decimal places, I have 1, 2, 3, 4 decimal places in the original question. So if I jump over 1, 2, 3, 4, and I put my decimal place between the 2 and the 7, my answer becomes 22 and 791 1,000ths, or 22.791. And if you look, are those two numbers relatively close? Absolutely. So I at least know my estimate and my final answer are in the right area. All right, if you could press pause on the video and try the following. So please find the product for the following and take your time. There's a lot of numbers there. It's easy to make a tiny little mistake. And we'll give you a chance to try that on your own. So just press pause now, please. Okay, welcome back. So we're going to multiply 4.52 times 2.6. All right, and I'll do this with column model number 2. So 6 times 2 is 12, carry the 1. 6 times 5 is 30, plus 1 more is 31. Carry the 3. 6 times 4 is 24, plus 3 more, 27. I move to the second digit, so now I need a placeholder of a 0. 2 times 2 is 4. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 more is 9. Add up the parts. And then count decimal places. So I have 3 decimal places in my starting value. So if I jump over 1, 2, 3, I get an answer of 11.752. And if I was to cover up the decimal places here and just have a 4 times a 2, that would get me an 8. So I know as an estimate, 8 to 11, they're at least in the right area. Okay, we'll try the second one here. Now this is going to be a big one because we have a lot of decimal places going on here. So 4 times 5, 20, carry the 2. 4 times 4 is 16, plus 2 more is 18. 4 times 5 is 20, plus 1 more is 21. I'll try and go a little quicker. I need a 0 for a placeholder. 8 times 5 is 40, carry the 4. 8 times 4 is 32, plus 4 more is 36. Whew. 8 times 5 is 40, plus 3 more is a 43. Okay, we're almost there. Last one, I need 2 placeholders of 0. So 1 times 5 is 5, 1 times 4 is 4, and 1 times 5 is 5. Gotta love multiplying by a 1. Add up the 0 column, add up the next column. So that would be an 8, 6, 5, 11, 12. 1, 3, 6, 10, carry 1 more, 5, 4, 10. Whew, that's a big number, or is it? So if we look, we have 4 decimal places. 1, 2, 3, 4. I put my decimal place, and my answer is 10.028, or 10 and 28 1/1000ths. Whew. So if I did a quick estimate just to see if my number is reasonable, if I estimated this as a 5 and I estimated this as a 2 and I multiplied those together, I would come up with a 10. And you notice, hey, those are pretty close. I must have a good answer. So thank you for watching. Please watch again and pause where you may have had difficulties, and good luck in your future math problems.